morning all of you. Today we are going to study about the theory of computation, and my today's topic is the introduction of DOC, uses of DOC, scope of DOC and Mille-Murray machine converter. Generally we have to know that what is the DOC. DOC is the core part of the computer science in which we study about the computational model which describe the limitation and capability of a particular machine, in which we study that what kind of a mathematical model can perform the particular task and what are the limitations for that particular model. Means generally we study about the algorithm of a mathematical model, but we don't express the capability of that particular model. So in the DOC part, generally it is used to design any kind of compiler or computational devices. So next is DOC is the branch of computer science which deals with the problem, how can the problem be solved by the using of the algorithm and the efficiency of that algorithm, and studies abstract model of computation. Means to solve any kind of problem we are using the algorithm. Generally we study the uses of the algorithm in the DSA also. We don't know about that what kind of problem can be solved and at which level that can be solved. And the efficiency of these problems, these algorithms means algorithm always should be explain the system of the particular problem resolution capacity and studies abstract model of computation. Next is the key area of the DOC. Automata theory. Generally it is used in the automata theory. Automata theory basically defines the any kind of automatic machine which accept the input from the algorithm based and the formal language. Formal languages are the languages which are used to design the particular automata. Automata is the abstract model which perform the task, any task on the automatic basis by the application of the instruction input. And formal languages are the many kind of formal languages are being used. Generally regular language, irregular language are used, and irregular language is also known as the contextual language. And the regular language in which we use the regular grammar. And computability theory in which we decide that how much efficiency in perform the computational model. And complexity theory. Complexity, generally two type of complexity we study: time complexity and space complexity. So the model projected model should be in such a way that which can resolve the time and space complexity by the using of DOC model. Next is the usage of the theory of DOC computations, being the designing efficient algorithm. Means the goal is to design efficient algorithm which solve the particular task, and the compiler constructions, as I earlier told you that the compiler construction always uses the DOC principles. And natural language processing, NLP, is basically used to process any kind of instructions which are applied on the part of the regular language and conflict classification. And cryptography and network security, it is the part of the security part in which we use the security areas which are basically needed for the particular transmission of the input symbols. And software development tools, various kinds of software development tools are used in the DOC, which uses the scope of the DOC constant. Next is scope of the DOC, and it is the scope of the DOC which describes the utility of the DOC, foundation of advanced computer science topics which are helping in the designing better programming language. It is basically used in that area where we study about the scope of the programming languages by the using of natural language processing and the regular language and irregular language. And we study here the finite automata, deterministic finite automata and non-deterministic finite automata, and basically push-down automata and Chomsky classifications are also used in this constant. Introduction to finite state machines. Generally, we studying that POC and finite state machines are prepared by the using of the POC principles. Finite state machines are there are two kind of finite state machines: Mealy machine and Murray machines. Generally, we know that any machine to which we design, the output depends upon the present state or present input. So it is the classification area in which Mealy machine and Murray machines are designed. So here is the tuples of the Murray machines. About the Murray machine, in the Murray machine, output depends only on the current state. Generally, in any kind of finite state machine, there are the initial state and there are the final state. So in Murray machine, output depends only on the current state, where the tuples are like that. Q, capital Q is the set of states, and sigma is the input symbols, and here is the triangle symbol, output symbols, and state transition symbols. Delta, lambda is the output function, and Q naught is the initial state. So these 7 tuples are used in the Murray machine. Murray machine is that kind of machine in which output depends only on the current state. Next is the Mealy machine. It is our Mealy machine. It is also the part of the finite state machines. Generally, finite state machine and infinite state machines are that kind of machine in which various kind of input and output are displayed. So Mealy machine, it is my Mealy machine in which output depends on the state and input. Where in the Murray machine only on the present state, while in the Mealy machine output depends on the state and input. And here represented as capital Q. Capital Q is the set of states. Sigma is the set of alphabets, and it is the triangle is the output symbol. Delta is the transition function. Lambda is the transition areas, and Q naught is the initial state. And output is produced during the transitions. It is the Mealy machine concept of the Mealy machine, and that was the Murray machine concept, where in the delta is the state transition function and lambda is the output functions. In the Murray machine, the basic difference is that output depends on only current state, while in the Mealy machine output depends on the present state and input. So difference Mealy versus Murray. Here it is the main part. What is the difference between the Mealy machine and Murray machine? So the feature we are using here is the output timing and states. So if we talk about the output, then in the Mealy machine output depends on state and input. Okay, and in the Murray machine output depends on present state only. Right. Second part is the output timing. If we talk about the output timing, then in Mealy machine output timing only depends on the transition of the transition. Transition means present state to next state. So in Mealy machine output timing only depends upon the on transitions, and Murray machine output timing depends on the state entry. Means at which one state to next state is transmitted. And next feature is the states. States we are using here is the initial state, final state, and transition state. So in the Mealy machine, states depend upon the generally fewer or generally more. It means in Mealy machine, transitions are changed overcome by the using of these principles. So conversion Mealy to Murray. What is the how to convert Mealy to Murray machines? So generally we know that the Mealy and Murray both machines are the finite state machines. So here is the for conversion, how to convert Mealy to Murray machine. So for each Mealy transition, output create a new state in Murray. In the Murray machine, every time it generates a new output and it associates with the output with the new state. Means in the Murray machine, output depends on the current state. So and the result more state but same behavior. Means states are different, but it shows the same kind of behavior. Conversion example: Mealy to Murray means how to convert Mealy machine to Murray machine. It is a visual representation of the Mealy machine, and converted Murray machine down shown means it is if any kind of Murray machine are converted into the Mealy machine, it means that is describing the present state and output state also, and duplicate state also generated in that case if there are multiple transitions depends upon the single input, then duplicate states are shown. Now Murray to Mealy, in that case we use the current state and input to determine output. So if we have to determine the output, we have to know about the current state of the Murray machine, and combine transition with the corresponding output means in that case if there are dead state or duplicate state, then combined transitions are explained in the Murray to Mealy conversion, and some states needed to be changes in that cases where are on a common input there are multiple states, and here is the conversion example original Murray machine diagram, and we need original Murray machine diagram to know about the transition of the particular state, and if we are going to convert into Mealy machine, then it is shown the next areas. And summary, TOC is fundamental to CS theory. It is basically needed for a part, and Mealy and Murray machines are the key finite state machines, and it is the understanding the conversion that helps in the modeling system efficiency. So in this lecture, this is the here is the TOC is fundamental to CS theory, means in the part of the theory of computation. CS theory are used to design the compiler like computational models, and in the computational model we will describe the limitations and capability of the particular abstract model where finite automata are used, and finite automata we use here deterministic finite automata, non-deterministic finite automata, and the push down automata. And here are the Mealy and Murray machine, which are the key of the finite state machine, and it shows the in which machines we use the present state, final state, and which state depends on the current state, either on the current input. And it is my understanding that conversion helps in the modeling system efficiently, means how to convert Mealy machine to Murray machine, and how to convert Murray machine to Mealy machine each other. So now we see on the Google that how our topic is the utilized and scope of the area. So here I am searching that particular topic, means importance of POCs, with Mealy and Murray machine. It is the part of the Mealy and Murray machine. Here we are looking at Murray and Mealy machines are transducers that help in producing output based on the input of the current state or previous state. As we studied in the previous PPT slides, that in which machines output are depending on the current state and current input. So we are looking here that the Murray and Mealy machines are transducers that help in producing output based on the current state or previous state. In this article, we are going to discuss Murray and Mealy machines, as we are learning that. In the part of the PPT, we see that the Murray machine, how many tuples are used. Q is the finite state of the state. Finite set of states. Q0 is the initial state. Sigma is the input alphabet. O is the output alphabet. Delta is the transition functions which maps Q cross sigma Q state, and lambda is the output function which maps 2 cross to 0. Here it is the Murray machine. It is the very best example to understand how Murray machine works. It is my initial state Q naught. Every state is described by the using of the circle and if we use the arrow, it is the initial state. Okay, here if Q naught state except 0, it goes to state Q1, or if Q naught is initial state and if Q naught initial state except 1, it gives to next state Q2. Next we are looking at Q1 state except 0, then output will be 0, and if Q1 state except 1, the next state will be Q3. So here we are looking the transitions are depending on the state of and inputs are 0 and 1. Here we are looking that if Q2 state is here and if it is accepting 1, then it will be on that particular state, so there will be loop like structure. And in the case of 0 input, if that it is the very best example of the Murray machine. Here are the 5 states, Q naught, Q1, Q2, Q3 and Q4. All these states are changing either itself or to next state depending on the input symbols. Here input symbols are the 0 and 1. So Q naught is the initial state. How will we know that which state is the initial state? Here Q naught is the initial state. Any state which is using this right directional arrow, that state will be the initial state. If Q naught state is accepting 0, then the next state will be 1. If Q naught state accepting 1, the next state will be Q2. Here we are looking every output state depending on the current input. So the principle is that if Q1 state is accepting 0, then output will be 1, and if Q1 state accepting 1, means if we see about on this state, then there are two transitions, 0 and 1. Q1 state is accepting 0, it will be transited to the itself state, means loop like state, and if Q1 state is accepting 1, then the state will be Q3. So if Q3 state accepting 0, state will be Q4, and Q3 accepting 1, then the state will be Q2. So by the looking of this transition diagram, we are getting the main point is that every next state depends on the current input. So here the Murray machine examples, the length of the Murray machine is greater than input by 1. Means, how is it possible? The length of the output for Murray machine is greater than input by 1. It is by that it is already having that particular output 0. Now next is the Mealy machine. As we seen in the previous PPT that how Mealy machine work and what is the area of the working of the Mealy machine. So the Mealy machines are also the finite state machines, are the part of the finite state machine, and in the area finite state machine, the output value and their input value. Mealy machine are finite state machines with output value, and their output depends on the present state and current input symbols. Couples of Mealy machines are here. Q is the finite set of states, Q naught is the initial state, sigma is the input alphabet. What kind of alphabet we are using? Alphabet may be A, B, C, 0, 1, 2, 3, any kind of special symbol we can use for the input alphabet, and initial state or final state, every state is demarked by the circle and by the using of right class arrow. Here there are three states, Q0, Q1 and Q2. This is my initial state. O is the output alphabet, delta is the transition functions, and lambda is the output function. Now it is my Mealy machine. It is my Mealy machine. In the Mealy machine, there was previously added one output, but here it is not here. As we see here, Q0 is already having one output 0, but in this diagram we are looking that Q0 is not having any kind of output previously. If Q0 initial state is accepting 0, then the next state will be 1. There are two kinds of transitions we are looking here by the using of 0 or 1. If Q0 is accepting 0, the output will be 0 and next state will be 1. And if Q0 initial state is accepting 1, then the next symbol is here, we are looking here, it is used to show the output. Means Q0 is accepting 1, then the next state will be Q2 and output will be 0. If anybody asks us that in the transition of Q1, if it accepts 0, then what will be the output? So, if Q1 is accepting 0, then the output will be 0. It is the output part. If Q1 is accepting 0, then output will be 0 and next state will be Q1. It is the loop-like structure. So, this is my Mealy machine. Now, here we are looking at the Mealy machine and Murray machines, and we know about the conversion of the Mealy machine and Murray machine. Here are some differences, key differences between the Mealy machine and Murray machine. So, first difference is the output difference. Output means, as we seen that there were various kind of present state and output state. So in the Murray machine, output depends only on the current state, and in the Mealy machine, output depends on the current state, also on the current input. Number of states, for the feature of number of states in Mealy machine, it may be fewer as the output as is seen in the transitions, but in the Murray machines, there may be more than one state, but that state or duplicate state is seen in the Murray machine. Response time in the Mealy machine, it is the faster than the Murray, and response time in Murray machine, it is the slower than the Mealy machine. And complexity area, it can be more complex due to the combined state input cases, and the complexity in the Murray machine, it can be simpler due to the separation of the input behavior. Thank you.